Electricity. We use it without even thinking, when we turn on the lights, charge our phones, or open the fridge. But have you ever paused to wonder, where does electricity come from? How does it reach your home, safely and instantly? Before we explore this journey, let's step back into history. Thousands of years ago, ancient Greek philosophers noticed that rubbing amber could attract small objects, a simple static charge. But the real story of electricity began to take shape in the 18th and 19th centuries. Benjamin Franklin flew a kite during a thunderstorm to study lightning. Michael Faraday discovered that moving a magnet through a coil of wire could create electricity, a principle we still use today. Then came Thomas Edison and Nikola Tesla, who brought electricity into homes and lit up entire cities. From scientific curiosity to everyday comfort, electricity became one of humanity's greatest breakthroughs. But how exactly does it get from distant power plants all the way into your living room? Let's follow the incredible journey of electricity, from the moment it's generated to the instant it powers your devices. It all begins at the source, where electricity is generated. Our story begins at the power plant. All around the world, electricity is born in places called generating stations. These power plants come in many forms. Some use fossil fuels like coal or natural gas, burning them to heat water and create steam. Others harness the power of the atom in nuclear reactors. But regardless of the fuel type, the core principle is remarkably similar. Spin something called a turbine. Think of a turbine as a massive version of a pinwheel or windmill. At a fossil fuel or nuclear plant, steam is forced through the blades, causing them to spin rapidly. Hydroelectric plants skip the heating step, using falling water to turn turbines directly, while wind farms let the wind itself do the work. Some power plants are even switching to solar, where thousands of mirrors reflect sunlight to heat a fluid and create steam, or they convert sunlight directly to electricity using photovoltaic panels. But no matter the technology, the goal remains the same: spin the turbine. Connected to the turbine is a device called a generator. When the turbine spins, so does the shaft inside the generator. This movement revolves a powerful magnet around coils of copper wire. Thanks to the laws of physics, specifically electromagnetic induction, this spinning motion creates a flow of electrical energy in the wires. This is the birth of the electricity that eventually powers your home. Now, you might think this electric current could simply be wired directly to your neighborhood, but it's not quite that simple. The journey has only just begun. Once electricity is produced, it faces its next challenge: distance. Power plants are often far from where people live. Electricity must travel long distances to reach most homes, and moving it efficiently requires a process called transformation. Here's the thing: sending electricity over miles and miles of wire isn't very efficient if we use the same voltage as in your house. Voltage is basically the pressure pushing electrons along in a wire, and high voltage means those electrons move faster and lose less energy as heat along the way. That's why, right after being generated, electricity enters a device called a step-up transformer. Transformers are marvels of engineering. A step-up transformer takes the electrical energy from the power plant and dramatically increases its voltage, sometimes to hundreds of thousands of volts. Think of it like pressing the gas pedal before a long road trip. The extra push helps it travel farther with less energy lost along the way. Now, the electricity enters the transmission system, a vast network of high-voltage lines that crisscross the landscape. You've seen them: tall metal towers marching across fields, hills, and valleys. These are the highways of energy. Electricity flows through these lines at incredible speeds, traveling hundreds of kilometers to reach your town or city. Along the way, it stops at substations, checkpoints where it's monitored, controlled, and directed where it's needed most. But electricity doesn't just travel in one direction. It flows in response to a delicate balance between supply and demand. Think of it like a scale. On one side, you have the power being generated, and on the other side, the electricity people are using. For the system to work, the two sides must be balanced every second of the day. If people suddenly use more electricity, for example, when everyone turns on their heating during a cold evening, then power plants must increase supply instantly. If too much power is generated and not enough is used, the grid can become overloaded, and equipment can fail. So how do we keep the balance? Across the grid, specialized teams and smart systems are constantly monitoring and adjusting. They may signal power plants to ramp up or slow down. They can also draw power from storage systems like batteries, or even reduce demand temporarily through smart devices. This real-time control is what keeps the lights on, the trains running, and the internet flowing, every second, without pause. As electricity gets closer to cities and towns, the voltage is too high to use safely. So it enters distribution substations, where the voltage is lowered. From there, the electricity flows into smaller power lines, the ones you see running along streets or buried underground. It passes through local transformers, often mounted on poles or hidden in metal boxes, which lower the voltage even further, making it safe for home use. Now electricity is in your neighborhood. It's almost home. Before entering your house, it goes through an electric meter. This little box tracks how much electricity you use, which is how your energy bill is calculated. Then it reaches your breaker panel, which divides the electricity into circuits and protects your home. If too much current flows through, the breaker trips, cutting the power to prevent fires or damage. From there, electricity flows silently through the walls, into your lights, TV, kitchen appliances, phone chargers, and everything else we rely on. It's easy to take electricity for granted. It's invisible, silent, and always there when we need it. But behind every flick of a switch lies a vast, complex system working in perfect harmony. From giant power plants and spinning turbines to control centers balancing supply and demand, to metal towers and humming wires to your own living room, electricity travels a long, powerful journey to bring light to your life. But with great power comes great responsibility. As more people use electricity and as we move toward electric cars, smart homes, and digital everything, the demand keeps rising. To keep the balance, we must think smarter. Using renewable energy sources like solar and wind reduces pollution and helps build a cleaner future. Being energy efficient, by turning off lights when not needed, using efficient appliances and unplugging devices, helps reduce demand on the grid. And supporting smart technologies like programmable thermostats and smart grids helps the system respond better to changing needs. We all have a part to play. The journey of electricity is more than science. It's a story of human progress, innovation, and connection. It powers our homes, it connects our voices, it lights our dreams. And now that you know its journey, you're part of that story too. If you found this journey fascinating, imagine what else is happening behind the scenes of our everyday lives. Like this video if you learned something new. Subscribe for more stories that spark curiosity, and share it to light up someone else's world. Thanks for watching. Stay curious, and stay connected.